Welcome to the Just KNIME It Recap. If you haven't heard of Just KNIME It before, we provide you with a weekly data science problem and challenge you to solve it with a KNIME workflow. In the recap, I'll give some of my thoughts on the problem and highlight a few solutions from the community on the KNIME Forum. Last week's challenge was on some systems administration work, really. It highlights some of the areas for a data system like KNIME outside of traditional analytics. We access some file system information and try to optimize some work in that space. So let's jump into the challenge and look at some of the solutions. You are reorganizing a data warehouse in your company, working with a file system that creates parent folders if you give a reference for a child folder. For example, if you ask the file system to create folder 1/folder 2, and neither folder 1 or folder 2 exist, it will create both with folder 2 inside folder 1, without raising an error. Given a list of folders, you want to keep only the longest unique child folders, filtering out references to parent folders that will be generated anyway for efficiency. So this challenge, I think, is a little confusing to wrap your head around first, but isn't too bad of a process once you understand what it's asking for. So this first solution is by Tusa. We've seen him a few times now, and I was back and forth on whether I wanted to show this solution first or last for this week's recap. That being because it's only 3 nodes, but I really decided to show it first because I think it gives us a really easy way of understanding what the challenge was asking for. So what we have at the beginning of the challenge is this table with all of these different folder pathways. And the idea is that if my system creates folder 1, folder 3, and folder 22, if I give it this request, then I don't need to also create folder 1/folder 3 because those will be created automatically when I run row 1 here. So we want to filter out any redundant folder creation requests. So the way Tofusu does this is first with a string manipulation. So we remove that final folder and we're given this substring that is just the parent folder. And then using this reference row filter node where you select one column to use as a filter and a second column that is being filtered, we can say if that parent folder exists, then we can remove it because we're going to create it anyway. So we see that, for example, with that first row here. Because the parent folder for row 1 is folder 1/folder 3, then row 0 here will be removed by this filter. So that's all we're trying to do is remove any excess rows. Okay, so the other way, and the most common way that I've seen this solved this week was with some loops. So let's look at the second solution by jproudfoot111. So again, starting from the same place, starting with a counter generation, and we're really looping. So the real way that other people have been doing this have been with these loops. So we look at each row one at a time, and we say, if this row's parent is represented in the table, then we'll remove any references to it. So it's kind of the same idea. We're looking for that parent folder, we're removing it from the table, but that reference row filter node really let us do that all at once without a loop. One of the cool things about this solution is that it also came with a visualization. So this visualization here is an eChart view, and it shows the different branchings here of the folder system in question. And if you go through and you count these up and you look at all the end nodes, you'll notice that there are exactly 17, which is the number of file pathways that we want to have at the end in our efficient makeup. Okay. The final solution I'll show you today is from Elsa Mule, and this solution is another one using a loop. It's a slightly smaller loop, and it has an interesting node in here that I think is worth pointing out. It's not one that gets used very often, this subset matcher here. So this is an interesting node and an interesting solution because this kind of opens up some ideas for other problems that might be similar, because instead of just strictly removing them, we're matching these subsets directly. So what we're having here is we first break them apart. So this cell splitter breaks them apart, and we get these collection data types. And we're checking to see if any of these collections are contained as subsets inside of other collections. And you can imagine how that might enable you to do more analytics. beyond just the filtering. So this is a cool one that I wanted to show because of that subset matcher node. Now, next week's challenge will be on ChatGPT, a little bit of AI stuff. So tune in, make sure you do that one if you have some interesting thoughts on ChatGPT and how it can be used in KNIME. Use the hashtag Just KNIME It to submit your solutions on social media, and I'll see you next week for the next recap.